sketching this graph. Now, if you're watching this video, you probably haven't remembered what the exponential graphs look like. So let's think about what we would do if we're trying to draw any graph and we're not really sure what it looks like. What we'll probably do is do a table of values. So we'll try some x values, find out what those y values are, and from there try to work out what's going on. So it's always useful to start around the origin, around x is 0, and if we just take a couple of values to the right of that and a couple of values to the left of that. So on our calculator we are going to be doing 0.2 to the power of those different numbers. So to the power of 0 is 1, anything to the power of 0 is 1. Okay, it's just disappeared. Go back into our calculator, let's change that to a 1. So we've got a fifth there. And if we have 2 as our power there, we have got 1 over 25. So this is because of what the function actually is. It's actually the same as saying a fifth to the power of x, and then doing a fifth to different powers. But what's worth doing here is just what we're going to do if we encounter any function we're not sure of. So now if we put -1 in, we get 5. And if we put -2 in, and some people might be there ahead of me already, but if you put -2 in, we're going to get 25. So what's this graph going to look like? Because we're being asked to sketch it. Where does it intercept on the y-axis? So on the y-axis, that's when x is 0. So we can see that we've got that piece of information. So at 1, the graph is about a fifth. Now at 2, it's getting smaller. So it's smaller than a fifth, it's a 25th. It crosses this axis here at the point 1. At -1, it's all the way up at 5. And at -2, if we're thinking about this as to scale, it's off the scale there, but it's up here. So when we're drawing this graph, it's going to be an exponentially increasing curve. So let's start down here, make sure we cross at 1 and go up. Now, the points that I've plotted are not important because the only important point is showing where the graph crosses the y-axis. So I'm just going to sort of tidy this graph up a little bit because I don't really like the way in which it's come out. So instead, because now I know what it looks like, I'm going to draw the curve first. Then I'm going to put my axes in. Then I'm going to put my axes in. And I'm showing that it's getting closer to 0, but never quite going to meet, which is what the exponential curve is going to do, crossing at 1 there. And that's enough information for my 2 marks. Now for 2b, so for part B, I'm now looking to solve the equation when it's equal to 4. So 0.2 to the power of x equals 4. Now there's 2 ways you can approach this question. You can approach it with the definition of a logarithm. So log a b equals c, which means, so when we think about what that's equivalent to, it's a to the power of c equals b. So if you remember that definition of a logarithm, we can rewrite our equation in logarithmic form. So it's going to be the a is the base, so it's log 0.2 to the power of c, which in this case is 4, equals our unknown x. And then if we pop it into our calculator here, using this log function, which allows us to change the base, 0.2 and 4, which gives us our correct solution for x. So we've got that x is equal to, let's just bring that back up. It asks for 3 significant figures, so we need to make sure we're doing that. So it's 3 numbers after the zeros have finished, so it's -0.861. -0.861. So that's your first option. Your second option is to just take log of base 10 of both sides. So we just write that as log, we don't need to write the base, 0.2 to the x equals log to the base 10 of 4. And then using the third law of logs, we can move this power down to the front. So x log 0.2 equals log 4. So therefore x must equal, if we divide both sides by log 0.2, we get log 4 divided by log 0.2. And if we then put that into our calculator, so it's log base 10 of 4, I'm going to close my bracket, over log base 10, 0.2, not 2 points, there we go. We get exactly the same solution of minus 0.861 to 3 significant figures there. So in either method, we are showing that we're understanding our use of logarithm and able to work that one through. So 2 possibilities. You don't need to do both, you just need one of the 2 methods. I would say the second method is more useful because it would help us solve more complicated problems, but the first method shows you understand the definition of a logarithm. Now finally, part C asks to describe the geometric transformation that maps this graph 0.2 to the x onto the graph of y equals 5x. Now what you could do is again try and sketch this graph and see what happens, and in doing so you would get the graph of 5 to the x, which looks like this. And if you've done that, then you've identified that it's a reflection in the y-axis. So that's one way you could go about doing that question. So another table of values and go from there. And I'll just remove some of the workings here so that we can see a different way of going about this. So it's only worth 1 mark. What we're being asked to spot here is that the original curve y equals 0.2 to the x is the same as 1/5 to the x. And we're looking to say, how do we get from 1/5 to the x? What transformation takes us from 1/5 x to 5 to the x? And if we imagine 5 to the x being written as 5 over 1, you can probably spot that this is a reciprocal relationship. The first fraction, 1/5, has been flipped over to give us 5 to the x. And how do we flip a fraction? We take it to the negative, to the power of -1. So we end up with this idea that the x value has had a -1 put in front of it. So effectively, the transformation is 0.2 to the power of -x, y equals. And from our definitions, if you've remembered your 2 reflective properties, if the negative is in front of the x, then it is the x values which are changing, and therefore it is a reflection in the y-axis. So the correct answer is reflection in the y-axis. And that's what you're looking for. It's only for the 1 mark there. Any other possibilities, any other combinations do not get us the marks for this one. We are after this specifically, reflection in the y-axis.